Swayam Prabha. Digital India. Educated India.
Hello. So we are going to talk about a very interesting area, which is basic surveying. And let me introduce myself. I am Dr. Bharat Lohani. I am a faculty in Department of Civil Engineering in IIT Kanpur. And over the course of all these lectures, I will be talking about this basic surveying. What we would like to do, we would like to start this with that what is the kind of structure for these lectures is. Because I have organized these lectures in a modular way. Now, what is the meaning of the modular way in this case is, all the lectures are clubbed in such a way that if you take one lecture, it will be kind of independent one, but it will be always helpful if you can go through all the lectures. So in all, we have defined around 13 main modules, and in all these main modules there will be further chapters. So a module is basically a major chapter in basic surveying. So there are 13 basic chapters, and in each chapter there will be further lectures 1 to 5. Now it is suggested to you, because when you are viewing this video, that you should view these videos in a series starting from 1 to the end. So in all there will be around 40 lectures. However, if you cannot do that, you can still manage by viewing individual modules independently, because this is how these modules will be designed. The only thing is, you will need some background of the previous modules so that you can understand what is there in the next module or what is in the present in any module. Well, in all the modules, I should give you some introduction of these. The module number 1 is about an introduction. This is the introduction to the geoinformatics. Though the name of the video is basic surveying, but I would like to start with this geoinformatics thing, because geoinformatics is an area of which the basic surveying is a little part. So we will be talking about the concepts of surveying in the second module, which will have 4 lectures. Then we will be talking about an important area in the surveying, which is the linear measurements, followed by the compass surveying, where we will have 2 lectures. Then we will be also looking into the theodolite and the total stations, because these are the instruments which we make use for angle measurement, a very basic thing in basic surveying. And then later on we will be going for some control surveying that we will cover in triangulation and trilateration. Then the 7th module is about leveling and contouring. The 7th module of leveling and contouring is about basically the control in z dimension or control in vertical. There is a very interesting technique of plotting the details in basic surveying, and this technique is called plane table or plane tabling. In short, we write it as PT. So we will cover this in 2 lectures. Finally, all the measurements which we take in basic surveying, because there is a lot of computation involved, we will need to compute a lot, we will need to adjust for the errors, because all the measurements which we will be taking or which we will be talking about will be subjected to some kind of error. So we will need to adjust for those errors, and this is very important module or the chapter in basic surveying. So please don't miss it if you are following this video lecture. Well, when we are talking about the basic surveying, we must also talk about the maps. Now in the maps, or in this particular module, we will see what is the agency in India which can provide you the maps, what are the scales at which these maps can be obtained, what are the prices, and where from you can purchase a map. So all this will be covered in one lecture. Finally, we will talk about the project surveys. There we will talk about some civil engineering structures where we would like to apply the surveying. Whatever we learn in other modules, we would like to apply it there. Then towards the end of my video lectures, we'll be talking about in 3 lectures about a technology called GPS. This is the global positioning system. It's a new method of doing the surveying. Well, how I have designed this course structure and what is the objective that I'm keeping in mind, because when I'm talking to you through this video lecture, I'm thinking in my mind that you should be able to do certain things. Number one, you should be able to understand the basic concepts of basic surveying. You should be able to understand that what this area is, how to do it, why we do it, what are the techniques, what are the instruments, and everything. Another important point, you should be able to apply surveying techniques and equipments in real life problems. This is very important. If you follow the video lectures carefully, if you understand each and everything in the video lectures, I'm sure you'll be able to apply these techniques and these equipments in any real life problem. Because once you are in a field, you have an actual problem in front of you where the measurements are involved, you will need to apply these techniques. So my aim of these lectures is so you feel confident enough at the end of the lectures that you can apply these techniques. Another important point, and that is problem solving in an optimal way. While we do surveying in the field, there are many possibilities, hundreds of possibilities a single problem can be solved by. Now, out of those hundred of possibilities, which one is the best one? That is the point. So what we have to do, we have to find a solution which is optimal. Optimal in the sense that optimal in terms of the cost, the time, the resources, accuracy, and all those things. So by doing this course, I will keep talking about these issues time and again. I'll keep informing you about the accuracies which are there, the limitations of the methods, the strength of the method. So whenever you are in the field, you are going to apply these methods, you should make use of these things which you are talking in this course, so that your solution in the field is an optimal solution. And at the end, this is a very important point, that I want you to understand the pitfalls of this particular basic surveying. When I say this, I mean what are the sources of error. Because if you don't understand this, it might happen that you will end up with your data, your problem, or your result with some error. We don't want to do that. What we want to do the work in the most optimal way. So we have to understand that what are the pitfalls in this particular technique. Well, so our first lecture today is about an introduction, and this is introduction to the geoinformatics and basic surveying. Mostly today I will talk about geoinformatics, because geoinformatics is an area which encompasses many disciplines, many fields, of which basic surveying is a little part. Because we are going to talk about basic surveying, so we should know where it belongs to. If you are reading about the basic surveying, you should know where you are ultimately going to. What are the modern techniques in order to carry out basic surveying? So in order to understand that, we will start with the basic term geoinformatics. What is the definition of geoinformatics? The definition of geoinformatics is geo, information, and matics, as written here. So it is geo plus information plus matics. The meaning is, geo stands for anything which is on the surface, slightly below, slightly up of the earth. Information about those features which are there on the surface of the earth. Then matics stands for measurement. So we are going to measure whatever is there on the surface of the earth, slightly below, slightly above. In addition to the measurement, one more aspect of geoinformatics is that is the management. So we measure the geoinformation as well as we manage the geoinformation. So this measurement and management of geoinformation put together is called geoinformatics. Well, to start with, we are talking about geoinformation. what the geoinformation is. We should understand this. As far as the definition of geoinformation is concerned, we can say, as it is written here, any artificial or natural object, phenomena on, below or above the surface of the earth. Well, some examples of that. Now here in this diagram, or in this, I can say the sketch, what is the geoinformation? We can find the geoinformation in terms of the roads or the houses, maybe a tower, the topography, hills there, the jungle, the forest, a water body, the hedges, a playground, another playground, or maybe some house and the fields, some other land use or land cover. So this is all is the geoinformation. So whatever you see on the surface of the earth, or we also go slightly below it or maybe slightly above it, is the geoinformation. Now for this geoinformatics, generally what I do, I try to define geoinformatics in two basic divisions, because this is very important. In order to understand geoinformatics, whatever we will be doing henceforth, we should understand these two philosophical divisions in the geoinformatics. What these two divisions are? Number one is measurement of geoinformation. We need to measure what is the geoinformation, because we have seen what the geoinformation is, everything on the surface of the earth. So we need to measure it. Now in measurement also there are two parts. This is very interesting and very fundamental, so we should understand this. First part in measurement of geoinformation is geometry. We want to see what is where. We'll explain it by an example in a moment. Then we also want to know that what is what. That is the identification. Here is an example. Well, let us take, this is the terrain or the ground, and on that ground there is certain object. Now this is the geoinformation here. This object is the geoinformation. Now we want to measure this geoinformation. What is the meaning of that? The meaning of that is we need to define a reference system like the coordinate system shown over here, and we need to fix the coordinates of this particular geoinformation, this feature. So we want to measure the x, the y and the z. So the moment we measure x, y, z in our reference system, the geoinformation is measured. But measurement is not enough. It's not enough, because we need to also do another thing, that what we have measured, what is there on the ground, what is the feature. So we need to go for the identification. Now what is the meaning of the identification? Identification means what we have measured. Is it a tree? Is it a road? Or is it a house? Or a garden? Or a hedge? Or a boundary wall? Or the hill? Or the river? So we need to identify this also. So basically whenever we are talking about measurement of geoinformation, we will be doing these two things. Number one, we will be measuring it in terms of a coordinate system. We will fix the x, y, z coordinate of it. And the second thing that we will do, we will try to identify it, that what we have measured. Well, the second aspect of geoinformatics, because I was saying that geoinformatics has got two fundamental divisions. One is the measurement of geoinformation. The second one is about, well, take it like this. We have measured the geoinformation. We know the x, y, z coordinates of a particular feature. We also know what the feature is. But what to do of this? What to do of this information? So the second aspect of geoinformation is, or the geoinformatics is, management of geoinformation. As we have written here in the slide, we want to manage the geoinformation, because just measurement, identification is not enough. Now for example here, if you look at the slide, here in the previous slide, we are talking about the measurement of geoinformation, and now here we are talking about the management of geoinformation. The management means all the things which we had measured, we had identified, we are trying to plot them here, as you can see in the slide, using a map. So we are retaining them for our use later on. We are storing the data in a particular format. What we had done, for example, in this map, we had measured there in the ground all the roads where they were. We also identified what are the roads where they are leading to. We also identified where are the fields. We also identified where are the areas which are occupied by houses. So our measurement and identification was complete. So the management of this information means we want to put this information in such a way so that we can store it properly. Not only storing, we want to retrieve this information later on. So the retrieval. Now with this map, what all we have done? We have stored the information in the form of a map. Anytime you want to know about the map, you want to know about the geoinformation, what you need to do, you just take the map out, start looking at the features. So what you are doing, you are retrieving the information from the map. And then the presentation. Of course, the map is a way of presenting this information. We could have presented this information, what we measured there in the ground, maybe some other way also. For example, the names of the roads, their lengths. So we could have made a table. So that is also a way of presenting this information or maybe managing this information. But our information here is the geo information. Geo means which is spread in the terrain. It's an spatial information. So we want to present it in such a way so that information retains its own characteristic, that the information is presented also in a spatial way. And this is how this map comes into the picture. Now another aspect of management of geoinformation is manipulation. Now as I am writing here in the slide, manipulation means analysis of geoinformation so that we can come out with some results, some answers. One example here could be, as we can see in this map, let us say I want to start from a particular junction in the town and I want to reach the other junction here in the town. Well, throughout this street network, there are various possibilities. You can take a route, well, like this, or you may like to take a route like this. If the question is, which of these two routes is best? So what you need to do, you need to analyze this information. You need to do some kind of network analysis in your information. So that is also a part of geoinformatics. So what we do in geoinformatics, we measure the geoinformation from the field. We measure it by recording the coordinates x, y, z, and we also identify the geoinformation that what we have measured. Then we come to the office, we present the information, we store the information in such a way, either in the computers or in the form of the maps, so that we can retrieve it later on, we can present it in a proper way, and also with the help of the information, we want to analyze the information so that we can arrive at certain results. Well, having said that, as I was saying that we have to measure the geoinformation and we have to manage the geoinformation. So what I will do, I will give you a brief introduction of the tools which we use for measuring geoinformation. And when I am talking about this, we will talk about these measuring tools for geoinformation in the way they were developed. So we will start from the very primitive times, how people used to measure it, and we will come to the latest things, that how we are measuring the geoinformation now. Well, initially, the primitive techniques, as we all know, still if you go to the villages, you will find people doing it. We use either pace means you walk along, or maybe you use the hands. You say balist, okay, a particular length is so much, you make use of a hand, then you measure it. Or maybe you make a guess. Or maybe you also make use of some rods, some standard rods. So these are the primitive ways of measuring the distances. There are some very good examples in Vedic age methods of pacing. I will give you one example right now, and for that I will need to change the slide. So we are here in the new slide, and what in the Vedic age people used to do, I will give you just one example of the pacing. Let us say this is the ground and they would like to measure the quality of the soil. So what they would do, they would dig a hole there on the soil or there in the land, and they will fill it with water. So this hole has been dug and the soil is kept out, and now it is filled with water. Now in order to measure the time, what they would do, a person who is doing this job, or maybe another person, he will walk to his site, for example, let's say by 100 paces. So he will do this pacing 100 times, he is at a certain distance, and from that point he will come back. While he comes back, they will check again that where is the water level now. Depending how much the water level has gone down, they will come to know about the soil. So basically why I am talking about this? I am talking about this because the people who are making use of pacing, measuring distances, measuring time, using the human body in Vedic age also. Now I will go back to our previous slide. So we talked about this, just one example, how people were making use of the human body for measuring distances. Another one you must have seen in villages. This is very quite common. The patwaris, who is the grassroots level worker in a village who measures the lands there, they also make use of some devices, maybe in a form of a rod or some chain, in order to measure the land parcels. So that is also, I would like to say, quite primitive way of measurement. Then if you further go into the villages, still people, they measure their land, the area, using, for example, the nali and hath. So these terms may differ. I am writing nali and hath because the area from where I belong to, people use this. Okay, this particular area is 1 nali or 2 nali, that kind of thing. Now how it is related with the area of the ground is how much wheat or rice will be produced in that particular area. So this is how a relationship is there in how much wheat is produced from a particular field, and this is how they are coming to know about the area. So what we observe, in most of these cases the human figure was used, either the pace, the hands, or these things. Now after some time, when people started requiring accurate measurements, what they thought, that the human body was not good enough because all humans, they differed in their measurements. So if for someone a distance is 100 paces, for other person who is short in height, that distance could be 120 paces. So they wanted to standardize these things. So some new methods came for making these measurements. So that was the time when the land surveying, measuring the land, started. So the standard methods of measuring distances are chain or maybe tape. At the same time, people also wanted to measure the angles, because in order to determine the area, you also need the angle. Here is one instrument which is called compass. It's a very simple instrument and it works in the principle of magnetic needle. So there is a magnetic needle which will align itself in the magnetic field, and making use of that, it is possible that we can measure the angles. So people started making use of compass also. Some more instruments, for example the theodolite. This is also an instrument which is used for making the measurements of angles in a more sophisticated way, more accurately. However, the problem with the land surveying methods was, in most of the cases, these methods are very cumbersome. As I am writing here in the slide, they cannot be done in inaccessible areas. Because what you need to do, you need to go to that area and you need to occupy the point, then you need to carry out the measurements. So all these methods are kind of very cumbersome. They will take long durations in order to complete the survey. So considering this time, people started thinking of some other method. So the other methods came in the same form of land surveying, but with the development of electronics. What people started doing, they converted these instruments, which were conventional mechanical instruments earlier, into the electronic instruments. As it is written here, we have the methods now which are mostly relying on the instruments which make use of the electronics. And in this case, we have the instruments, for example, the EDMI. It's an electronic distance measuring instrument. Now to measure a distance, you need not to do the pacing, you need not to spread the chain, but what you need to do, you need to simply fire an electromagnetic pulse and it will tell you the distance. So these instruments are very sophisticated. Also, as seen here in the slide, we have a total station. This total station can measure angles, can measure distances all automatically without much involvement of a human being. So now the things have become very fast. It can do very accurate survey, it can do them very fast. There is another word which you see here in the slide, it says robotic. Some time back the total stations were like that a human being has to operate it. But now the total stations are developed to such a stage that a total station is kept in a place independently while the surveyor moves with a rod, which is also a part of the total station, everywhere in the ground. Total station will target that rod automatically. The surveyor who is moving with the rod will just press some buttons, and with the press of those buttons, the total station will carry out the measurements. So it's really very fast. A single person can do the surveying. However, in these electronic methods also, as we see here in the slide, they are still difficult. Difficult because you have to go to the ground. You have to occupy the point. I'll give you one example. Let us say you want to measure for a power line. This is the power line between two poles. You want to measure the coordinates of several points there in the power line. If you need to do it, using the total station is a very difficult exercise because you need to bisect each and every point. Another example, if you want to measure, let us say an area which is flooded, it's very difficult to go to that area. You cannot occupy the points there because everywhere it is flooded. So you cannot carry out the measurements. What you need to do, you need to wait so that the flood water will recede, then you will go to the ground, occupy the ground, then carry out the measurements. So in all the methods that we saw so far, either the primitive ones, land surveying ones, or the electronic surveying one, in all the cases you have to go to the ground, occupy the ground, and then take the measurements. So which is really difficult in case of difficult terrain, in case of inaccessible terrain. So considering this, people started thinking of something more. Some new measurement tools came for measuring the geoinformation. And here is one which I am writing in the slide, that is the aerial photogrammetry. As seen here in the picture, in case of the aerial photogrammetry, once it was developed, initially during the time of the World War I and II, people used it for spying purpose. What they would do, they will fit a camera in the belly of a pigeon, and the pigeon will fly in the enemy terrain, and it will take a single photograph and it will come back. So it was a very nice way, very smart way of taking the photographs from the air in this enemy area. So you have all the information about the enemy movement. So this is how the aerial photogrammetry developed. However, later on, we have started making use of balloons and as well as aircraft based. What we do now, I am going to give you an example. In the case of the aircraft, the aircraft will fly at an altitude of, for example, 2000 meters, 3000 meters, 4000, 10,000, depending what kind of application, what kind of photographs we are looking for. So while the aircraft is flying over the ground, it will take an image. It will capture one photograph of the ground. The aircraft moves further, it will capture another one. So like that, a series of photographs will be captured for the terrain. And these photographs we say aerial photograph. As we can see here, in these aerial photographs, we have some area which is overlapping. We'll make use of this in a moment. Now these aerial photographs could be either a single photograph, as we see here. This is a single photograph of the terrain, and in this you can see the road, the vehicles on the road, houses, the trees, some water pond. So we can now identify the things, one aspect of geoinformation. Not only that, if our photographs are stereo means, as we were talking in the earlier case, two overlapping photographs. From two positions of the aircraft, we have the area which is common in two photographs. So that kind of photograph, this photograph and this photograph put together, we say stereo pair. So if we have the stereo pair or the stereo photograph, it is possible to generate three-dimensional model of the ground. Now, once we can generate a three-dimensional model of the ground, what is the meaning of that? The meaning of that is you can now start measuring on that 3D model various things. You can measure the distances, you can measure the coordinates, you can measure the angles. So with the help of the photograph, as we are looking here, we can measure the XYZ coordinates, we can identify the things, so we can get our all geoinformation that we need to. This aerial photogrammetry also developed like anything. Earlier we had some analog way of taking the photograph, also processing them. In between came the analytical way, and now the modern one, just for your information, is the digital photogrammetry, where most of the things are automatic now. However, as we are writing here, still we need to fly to collect the data every time. Whenever you need the data, you need to fly with the aerial photograph, and this is not always possible. Why it is not possible? Because, for example, some area is flooded and you need to take aerial photograph of that area because you want to see how much of the area is flooded. You want to take the measurements. So in order to measure this, you need to fly using your aircraft. Now the problems: the aircraft may not be available, or the aircraft where it is available may be very, very far from the site where the flooding is taking place. So it's really very difficult to fly every time. You cannot do it immediately in many instances. The second thing, even if you can fly every time, it's a costly affair. Aircraft, they cost a lot. The crew will cost a lot. So it's a costly affair. So though the aircrafts were able to give us very fast, very accurate, and very, very synoptic everything on the ground geoinformation, we had some limitations from the aerial photogrammetry. Aerial photogrammetry, it is being used now depending upon the application. But people started thinking something more. Well, can there be something in this space which can go around the earth, can take the observations regularly? And the idea of satellite came in mind. So the satellites are such things, as we can see in the slide, they will rotate around the earth. They will keep rotating around the earth, and they will keep taking the images of the earth. They take because while the satellite is rotating, is orbiting, the earth will spin. So it is possible the arrangements are such that the images are taken all over the earth, everywhere. So what you have? You have now a system which can take the images repetitively after 5 days, after 10 days, depending the satellite. So this satellite remote sensing, it actually started commercially, I'm saying, because there were some spy satellites earlier also. The data of those satellites was not available earlier to the civil users. So this Commercial remote sensing, it in fact started in 1972 with a satellite that was called Landsat. Sorry about that. Landsat. That was a satellite by United States, and this data was available to the civil users. Generally, these satellites which we use for the Earth observation, they will be from 600 kilometer to 900 kilometer altitude. So from those altitudes, you just think of that, these are very high altitudes. The satellite is orbiting there, and you are able to capture the images of the Earth. So what you capture from the satellite may be a case like this. Now here in this, a satellite has captured an image of European countries, while we can see the Africa also there, the north part of the Africa. We can see the United Kingdom. Part of the Europe is in dark because it's an image of evening time. Part of the Europe, here in the UK, the London, the Ireland, they are still towards the evening. It's not dark there. While in other parts, the France and other parts, we can see the lights on. So satellites which are at very high altitude can capture images like this. Now this kind of view of the satellite, because it is capturing in one view everything, whatever is there, and a huge area, we say this a synoptic view of the terrain. But this kind of thing was not possible earlier. If you are doing land surveying, if you are doing aerial photogrammetry also, this was not possible. Then the second aspect, satellites also take images in several wave bands. What is the meaning of this? The meaning is, it doesn't take the image only in optical. It can take images, it can take the photographs or the imageries also in microwave. Now, if there are some cloud covers over the area, for example, let's say in this slide, there are some cloud covers. These are the clouds. If we are taking the image in optical, then because of the cloud, we cannot observe the ground. In the satellite image, we will have only the cloud. So if you are using the microwave remote sensing, it is possible that you can see beneath the cloud. So there is a term called spatial resolution in satellite remote sensing. Earlier, the satellites, the commercial satellites also, they had a spatial resolution of 80 meter. Now what is the meaning of that? To understand the meaning of that, you need to see this slide. In this slide is a synoptic view. We can see the entire continent, but we cannot see the individual streets here. We cannot see the individual houses. So the resolution of data is very poor. However, in this slide, as you see, we can see the individual cars on the road, the houses, bridge, maybe some boats here, some more cars, individual trees. So everything is clearly visible. Now this is the data from Iconos satellite. The resolution of this satellite is 1 meter. So we have in commercial arena some satellites which can give you the resolution varying from kilometer to meter. Now it depends what kind of your application is. If your application demands huge areas, big areas, then you will go for resolution in called kilometer. Your application is something like forest mapping. You don't want to measure each and every tree. Your area, you want to measure the entire extent of the forest. So it is advisable not to go for a data which is very accurate. The resolution is only 1 meter or half a meter. But if your application is, you want to measure the individual cars on the road. You want to measure the outlines of the buildings. You want to measure where exactly the trees are. You want to measure what is the outline of the river exactly, very accurately. So for most of engineering applications, we need accurate measurements. So it is possible that we can get these accurate measurements with the satellites which have a spatial resolution of order of 1 meter or slightly around. So we have at the moment the best resolution commercially available of around half a meter. So it's a very good resolution. You can see many details, a lot of information in the data. Now this satellite data also, because we are talking about, I will take you back again to what we started with. We started with the geoinformatics, basically two divisions, measurement of geoinformation and management. Then in measurement of geoinformation, again two things. Where the information is, that is the XYZ coordinates. The second thing, what the information is. So we can make use of satellite data, as we can see in the slide, for both the purposes. We can do the measurement here and also we can do the identification. Well, you can identify in this figure the bridge, buildings, roads, cars, everything. Now with some process which we do in remote sensing, it is possible that I can assign coordinates also to each and every point, not only in X and Y but also in Z. So by that measurement you know the XYZ coordinates also of each and every point. So if you want to measure the distance along this road, the distance is known to you. So now see how the things have changed. Earlier you were supposed to go to the ground, occupy this point, but now you are not going to the ground. Rather you are making use of satellite image, and using that image, satellite image, you can measure the distances. You can also measure the angles. For example, the angle between these two streets, what this angle is. So we can make use of satellite remote sensing for both measurement and identification. Another interesting thing I just wanted to show you, because this is very important data, the satellites do take repetitive data. As I told, they will cover your earth every 5th day, 9th day, 18th day, 22nd day, depending which satellite we are talking about. Here is a data from digital globe. The name of the satellite is QuickBird and the resolution is half a meter. This is the data from Indonesia, and this is the data just before the tsunami of 26 December 2004. So this is the area which was, the area used to look like this before the tsunami, with houses, fields, the trees, more fields, houses, the jungle. Now after the tsunami, again the satellites, they captured the data. Now how the data looks like? The data looks like this. Both here and here, both are same. So we can see the areas which have been flooded now. So you can do this mapping very quickly using the satellite, all the areas which have been flooded. You can also make use of this data in order to see the damages to the buildings. All the buildings have been damaged. One little building over here, still the roof is intact. So we can guess that this building didn't damage. While for all other buildings, they have been damaged. You can see the debris. Everywhere the debris is falling. So this is how we can make use of satellite image in order to collect geoinformation, both measurement of the geoinformation as well as management will talk later on. But for geoinformation, knowing where it is, also knowing what it is. One more modern tool. This is a modern tool which we say the GPS, Global Positioning System. Now what this GPS is, because since the beginning itself, we always wanted to know where we are. Okay, in the Vedic age also, people found some ways to know where they are. They made use of the stars, the sun, the moon and all those things. We wanted to know our location because our location is very important to us, because we want to see my location in relation to other things. So the GPS is the instrument which can give one's location very accurately. What the GPS is? In the case of the GPS, as we can see here, all around our earth we have around 24, I am saying 24 at the moment, though it's not exactly 24, it's more than that, number of GPS satellites. And these satellites are orbiting the earth in such a way that at any moment of time, if you are standing anywhere, you can see at least 4 satellites, of course more than that. What you have a receiver. A receiver of the GPS may look like this, or maybe it will be a simple handheld device like the mobile phone. This receiver measures your distance to 4 satellites, as we can see here. So there is a method, we will see this method later on. So by knowing these 4 distances, also by knowing the location of these satellites exactly at the time when we are measuring the distance in a coordinate system which we define at the center of the earth, it is possible for us that we can determine where this receiver is. So wherever you go on the surface of the earth, you are standing here, by using the GPS receiver, you should be able to determine where you are in this coordinate system. It's a very good instrument. That little instrument which is the size of only a mobile phone. You go about with this anywhere. If you are walking with this instrument, it is possible because this receiver is measuring the distances to 4 satellites. And immediately by the computations, I will come to know where I am. What are the latitudes, longitudes and altitude of the point where I am standing. So anywhere you go around the earth, this is possible. Now what you can do? If you know the latitude of this place, all the coordinates, latitude, longitude and altitude of 2 points on the surface of the earth, you can measure the distance between 2 points. If you know the lat, long and altitude of a third point also, you can also measure the angles. Well, some more points, you can find the area. So now with a single GPS, as you move, your coordinates are being measured automatically and independently. So you know the coordinates of this point, coordinates of this point, coordinates of this point, coordinates of this point. And if you know the coordinates of all these points, the area of this field is known to you. So it's a very interesting way of carrying out the measurements and a very, very modern way. Now as we are saying, there are at least 24 satellites which we need to make use of, and the coordinates are given. I am going to give you a term here which is called geocentric coordinate system. The meaning is the center of the coordinate or the origin is at the center of the earth. So all the coordinates wherever you are going with the GPS receiver will be measured in this particular coordinate system. Now about the global positioning system, it's very fast if you want to take slightly less accurate measurement. Okay, you can just run, you are in a car, you are moving in a car, and the GPS with you which is in the car is looking at the satellites, measuring the distance to the satellites and finding your locations. If you want to do it very, very accurately, say in millimeter level, you want to do it very accurately for some applications. For example, in the case of the earthquake, where let us say I am drawing this diagram. This is a fault and there is likelihood of a movement along this fault. Let us say I draw it this way. So we need to monitor this fault. Is any movement taking place there? So what people are doing now, several researchers, they are putting the GPS 1, GPS 2, similarly here also 3, 4 and so on. So what we have a network of GPSs which are kept all along the fault line. So we have a network like this. Now if there is any relative movement in between these two plates, So these points will move in relation to these two. What the GPS is giving us? GPS is giving us the coordinates regularly. So we know the coordinates of this. So we know this distance, or rather I can say we know this vector. So between 2 points I know the vector. Now this was my initial vector. Now this initial vector may change after some time. So this change in the vector in terms of the angle, in terms of the distance, is because of the relative movement of these two plates. So people are trying to make use of this kind of observation, the GPS observation, in order to predict the earthquake. Now another good thing about the GPS, you can use it everywhere, all over the earth, wherever you can find open sky. You can't do it inside the room because you need to see the satellites. So because it gives you a location, there are thousands of applications which are possible, and many more applications are being invented. GPS is going to be an essential part. In many mobiles nowadays, the GPS are there. Even in many watches, people are wearing the GPS in their watch. If someone is going to a forested area, they want to go to, a forested area. So there in the forest, they want to locate where they are moving. They carry a handheld GPS of the size of a mobile phone, and it keeps telling you, okay, you are moving in this direction. If you want to come back, look at your movement, how you had reached a particular point, so you have to just backtrack. So all these things are possible with the GPS. Now having seen all this, as initially I talked, for the geoinformatics there are two fundamental divisions. One, measurement of geoinformation. Now whatever we have discussed so far, the primitive techniques, land surveying, electronic surveying, aerial photogrammetry, satellite remote sensing, or the GPS, all these are the methods for taking observations, for measuring geoinformation. Also, all these are the methods by which we can not only measure X, Y, Z of the geoinformation, but we also know about what they are. Now the next aspect, once we have measured this information, we want to manage it. We want to store it properly. So that's the second aspect or the fundamental division of geoinformatics area, which is the management of geoinformation. So as we saw a little bit earlier also, we need to store our data. There is a requirement to store the data. There is a requirement for retrieving the information. We want to store it properly, and whenever we need it, we need to retrieve it. We need to get it back. So that is the management of the geoinformation. We also need to present the information. What is the meaning of that? Whatever you have accumulated, whatever you measured in the field, you need to present it. Maybe you want to make a map, maybe you want to make a table, maybe you want to make an extent, you want to give to a leader, a political leader, you want to show him, okay, how much of the area is flooded. He is interested in that. So what you do, you use the map of the town. On top of that, you want to draw a line which shows the area which is flooded. So that's the information presentation. So that is also a part of the management of geoinformation. Most important of all, because storing, retrieving, presentation, these are important aspects, but the most important of all is whatever geoinformation you have stored with you, you want to analyze it. You want to put all these information together so that you want to come out with some kind of final answer. One thing could be, one example, let us say we have a map of an area, and in that map we have the topography shown. I am just drawing it this way right now. We have some trees, we have the houses, everything. We have some villages here, having those houses and all that, fields, pools, river, everything. Now your job is, you want to start from a point A and you want to reach point B. So far there is no road in between A and B. So what you do, you want to join A and B by a road. So there are various possibilities. You can join them by a road which may go like this. You can join them by a road which may go like this. Which way? What is the best way? So what you do, you make use of the geoinformation which is collected. So for a problem like this, the geoinformation could be the geology of the area, the rock type, where the villages are, where the trees are, where are the fields, where are the schools, where are the towns. All this is the geoinformation. So you put all this geoinformation together, and then your computer, where this information is kept, analyzes this in order to find the best possible route alignment between these 2 points A and B. So that is an aspect where we do analysis of the geoinformation. Now in geoinformation, there is a term which is called GIS. GIS stands for Geographical Information System, and this GIS does all this management part. Whatever we are talking about, everything will be covered in GIS. Now I will like to end this presentation by one example of the GIS, and this is, the example is, there in some town there is the flooding, and we need to locate the areas where we need to provide the relief. This is a very important decision. You want to provide the relief in those areas where it is required. Now if this is the problem, now start thinking, in order to answer this problem, to provide relief to those areas where the flood is, what all information we need, what all geoinformation we need. So the geoinformation that we need, okay, how much area is flooded, we need to measure it. How do we measure it? We can make use of the satellite, or we can go to the ground, if possible, map it. We need, because we have to provide the relief, we need to know what is the road network in the area and what are the types of the road. What is the chance that a particular type of road has been washed away? We need to know about the topography. Why topography? We need to know about the topography because those areas which are elevated, if we know that the stage of the river or the height of the flood water is so and so, so we can make an assessment what all areas will be flooded if we know the topography of the land. Topography means the undulations. So those areas which are higher will not be flooded. We need to know about the pakka houses, because if you know about the pakka houses, the school buildings, any government building there, so we know, well, these are the buildings which will not be damaged. So the chances are people are occupying these buildings because these are not damaged. Okay, so distribution of where the one story and multi-story houses are. We need to know the probable shelters, where the people are really staying in the event of the flood. So having known all these information, there is a requirement now to take a decision where all this information will be put and a decision will be taken on the basis of this information. So what we need to do, we need to put all this information in a model. Now this model will run under GIS. It will make use of all these information to find the sites on priority basis for the rescue. So we'll need a model, and that model can be run on this GIS data, the geoinformation. So this is the management part of the geoinformation, where we are coming out with the areas. Yes, this is the area where the rescue has to be provided. This task, if we do it manually, is a very difficult task. So manual interpretation is involved, and conventional methods are involved, which are very, very difficult to carry out. So carrying out this task in a computer using GIS is suggested. Now finally, whatever we have done today, in our next video lecture, we'll talk in detail about the basic surveying. Because today we saw that what the geoinformation is, what is geoinformatics, and tomorrow we'll see what the basic surveying is, though we saw about it a little bit today. So this is what we'll cover in our next video lecture. Thank you.